This is page 208 and we're looking at question 23. So we have here, in snapdragons, flower colour can be red, white, or in the heterozygous condition, pink. So we can see here straight away that there's no dominance in terms of the actual flower colour. It's incomplete dominance. The second trait then, we have also tall is dominant over dwarf. So I've written in here snapdragons, that's what we're dealing with here. It's two traits. So the first trait that we're looking at is going to be flower colour. Flower colour. It says there's three outcomes, so we can have red, we can have white, and then the heterozygous condition is pink. So it gives us the letters in the question, so capital R for red, small r for white, and then capital R small r will be pink because that's the heterozygous one. Even if it didn't give us the letters in the question, we know because red is the dominant one, we would use the capital R for that. We then have the actual height of the plant, so height. And in the question again, it tells us that tall is dominant over dwarf. So we have tall, we have dwarf, and then in the middle we're going to have our heterozygous condition, but it does tell us that one is dominant over the other. So tall, capital T, dwarf, small t, the heterozygous is capital T, small t. Tells us in the question tall is dominant over dwarf, therefore we know that the heterozygous condition is going to be tall. The question states a dwarf red-flowered snapdragon plant was crossed with a homozygous tall white-flowered snapdragon plant. Okay, so really all we're looking at is working out our cross here. And so we start out as always with our phenotype, so what you actually see. It tells us in the question that a dwarf red-flowered snapdragon, so we have dwarf first of all, so it's dwarf, and then it tells us that it has red flowers, so dwarf and red, is crossed here with a homozygous tall white flowered snapdragon. So it's tall and it is white. So looking then at our genotypes, and so if it's dwarf, we know here that it must be small t. If it's red, we know it's capital R. So that's a nice handy start. Then we have tall, so we just need to go back to the question to check if it's homozygous or heterozygous. The question tells us that it's a homozygous tall white flowered snapdragon plant, so if it's homozygous and it's tall, we know it must be capital T. Then we know that it's white in terms of colour, so it must be small r. Okay, so that's what we're looking at in this case here. Then we have our gametes. So in this case here, the only thing this one on the left can pass on, remembering that it must have a T and an R in all the gametes that are produced. We have small t, capital R. On the other side then, again, we must have a T and an R in each, so we have a capital T and a small r. There's no other outcomes here, there's no other possibilities. When we come together then, we should do a Punnett square for this, but in reality there's no need because all the offspring are going to be the same, there's no variation between them. So our offspring, our small t capital R and our capital T small r come together. We're left with capital T small t, capital R small r. Now if we consult our index that we had at the start, our t's first of all, so capital T small t, the plant is going to be tall, and then capital R small r, it's going to be pink. So in the question, just going through the different parts here, it says the genotypes of the parents. So this one here is your genotypes of the parents, so we've worked those out. So genotype of parents. Then the second one that we have here, the genotypes of the gametes. So genotypes of gametes. So we've worked those out, we have them for each of the parents. And then we have the possible genotypes and phenotypes of the offspring. So we have our genotype, and then over here we have our phenotype of the offspring that are actually produced. So this was part C of the question, so this one actually worked out to be quite straightforward in the end.